In this video, we're going to talk about using spear phishing in order to target an organization. Now, spear phishing, basically the idea is that I know a little bit about the organization, enough to know who to target, which person, what type of information they may be interested in, maybe even have an in with the organization or that person in order to have some credibility with the attack that I'm going to be doing. So we're going to target one specific organization, in fact, one specific person in that organization, in order to then attack the group. So a little bit of background about our organization. This is our organization right here. And we may have seen this before if you've seen my other videos. Basically, the idea is that I am out here on the internet. I'm actually going to be using both of these machines in order to target this one Windows XP Pro. Now, the fact that it's Windows XP Pro and fairly old is not really that big of a concern to us. Ultimately, our goal is to be able to have a process that works, whether it's XP Pro. If it's a newer system like Windows 10, the tools change a little bit, but the process remains the same. So let's talk a little bit about how people might use this in the real world. So this right here is a network or a diagram by Lockheed Martin, referring to as the cyber kill chain. And it kind of gives us a nice little process of how a hacker may. So we start off right here on step number 1 with reconnaissance. Now, this reconnaissance can be everything from looking at things online about an organization, looking up individual information for people, physically going to a location and getting a feel for it, seeing what the physical security looks like, basically scoping out the environment and creating documentation about the environment, about what you see and how that might be used later. The next step is weaponization. Basically, we choose a tool in order to attack the organization. Once we have the tool created, we then use delivery, and as you can see from the icon right there, delivery oftentimes is performed in form of an email. Once we've gone with delivery, we can then start by exploiting the organization. So we delivered a tool, now we can actually execute some remote code on the system, do some sort of installation in order to remain persistent, command and control in order to perform various commands on the organization, and then lastly do some sort of an action on the objective against that organization, whether it was to steal information, so the confidentiality, whether it was to be able to change information, so integrity, or whether it was to bring the system offline to affect their availability. So this cyber kill chain is a way to be able to describe the process that most hackers go through, even if they don't necessarily know this process, or if they combine multiple phases together. This is the process that most hackers go through. Now, us as systems and security engineers, we can then look at this and attempt to identify if somebody is doing reconnaissance or against our organization. If, say, somebody's doing Nmap against our organization, we might be able to see that ahead of time. In order to identify that somebody's performing reconnaissance, we can then block those IP addresses from our organization to stop them from going into the weaponization, delivery, and other steps for attacking your organization. So the cyber kill chain helps both the hacker and the system security engineer to protect the organization by understanding the processes that the hackers go through. All right. So, we're using spear phishing to target the organization. In this scenario, the reconnaissance phase has already taken place. We're just going to assume that the reconnaissance has already occurred. We already know about the organization. We already know that they're using Windows XP Pro. That's the target machine. We also know what browser they're using. And we know the person who's using it. Because we have this information now, we can actually do what's called spear phishing. So instead of sending a massive email to everybody, to the entire organization, we can send it out to that one specific person in a way that will encourage them to click the link, and we can optimize our attack specific for that one person, that one operating system, and that one web browser. All right, well, with that all being said, let's go ahead and get started. Step number 1, weaponization. Actually, step number 2, weaponization. We've already done our reconnaissance, so we're going to create our weapon. So let's go ahead and jump into our Kali system. This is Backtrack, prior version of Kali. But we're going to go ahead and open up the Metasploit console. Metasploit framework, as you may or may not be aware, the Metasploit framework is a framework that holds multiple exploits that are publicly available for people to be able to use. A lot of these exploits are written by security researchers as a way to be able to explain the vulnerabilities that they're finding. Other people can then use these both for proper uses as well as for improper use. What we're going to do specifically is we're going to attack the web browser on this client. So if we go ahead and do a search, we want to search for browsers of a type of exploit. So this will show us all of the exploits of type browser, or of a name browser, and we'll see that there's all kinds of exploits. Let's see, there's a T-Chart Professional ActiveX control that is vulnerable to an exploit. Scrolling up, Roxio Cineplayer ActiveX control. Novell iPrint client. There's a lot of different vulnerabilities, including several for Internet Explorer. Internet Explorer, Chrome, Firefox, all kinds of those. In fact, if we do another search, this time for Firefox of a type exploit, then we can start seeing just a list of Firefox specific exploits. Same thing, instead of Firefox, we can type in Explorer, and see all the Internet Explorer exploits. Same thing if we have Chrome, Safari, Opera, whatever other browsers that might exist out there. Now, I know what you're thinking. Why would we necessarily be looking for Internet Explorer? Nobody uses Internet Explorer nowadays. Everybody's too smart to use Internet Explorer. Well, actually, if you go out to Google and we start looking for, say, most popular web browsers, 2019, we can see that, yeah, the most popular web browsers are, in fact, Google Chrome, Safari, Firefox, and Internet Explorer /Edge. Chrome, Safari, Opera's even in. Wow, imagine that. So that was just as of December of 2019. So when you think about Chrome, the people who use Chrome are the ones who know how to change the web browsers. But when you talk about Internet Explorer and Edge, this may be people who don't know how to change the web browser. So maybe you want to target that because they're possibly less educated people that you can more easily attack. Alright, so in this case, I'm specifically going to use an exploit. Windows browser MS09 underscore 002 underscore memory underscore corruption. And yay, I typed it correctly. I'm going to use that one because I specifically know, due to my reconnaissance phase, that this person is using this web browser. He's vulnerable to this attack. If I run the info command, for example, this actually gives me a little bit of information about the attack. See, right here it tells me it does something with the C function pointer function to access uninitialized memory. Can then corrupt the memory. An attacker can then corrupt the memory and execute arbitrary code. That's great. That's what I want. If I scroll up a little bit, it tells me a little bit more details. So there's the title, the exploit name, even the version. So if I'm running multiple, if one attack doesn't work, maybe I need to update the version to a newer attack version that will catch the situation that I am. Tells me the platform is in Windows, and then even tells me the available targets. Here it's saying specifically it has to be IE7, running on either Windows XP, SP2 or 3, or Windows Vista SP0. Now I know from my reconnaissance standpoint, my victim, my target, is actually running IE7 on Windows XP. So this is the perfect version that I want to attack. Alright, so if that's the one that I want to attack, then I need to look at my options and I need to start configuring things. Yeah. So first thing we might want to bring up is, why do we actually want to target a web browser? Firstly, is because a web browser is what a lot of people use. Throughout their entire day, they use web browsers almost nonstop. I'm actually using a web browser right this moment in order to access this virtual machine. It's just how it works. People use web browsers like crazy, nonstop throughout their day. The second is because web browsers are essentially operating systems at this point in time. Web browsers have all kinds of capabilities built into them, such as, well, file access. Web browsers can access files both locally and remotely. They have processes. You can run processes or apps inside of my web browser. They even have databases. And they are integrated so deeply within the operating system in order to optimize all of their activities that the web browser is a perfect way to be able to get into a system and further exploit it. Okay, so let's go ahead and do a show options. Metasploit framework, this is how we see what options are included for our possible attacks or our possible exploits. And we can see here name, current setting, whether the option is required or not, and then a description. For instance, there is a name, an option called SRV host. Current setting is all zeros, so it might as well be empty at this point. And it is required, and then has a description, the local host to listen on. We then go to server port, defaults to 8080, it is required, and that is the local port to listen on. I'll talk about that in just a minute as far as why we don't want that, why we don't want this. Next couple of options have to do with SSL. Ideally, I would love to be able to enable SSL and have my attack be available via SSL. I currently don't have the time to walk through the process of generating certs and having them be trusted and so on. Definitely look that up. It's not that hard of a process. And then the URI path, which is basically part of the HTTP URL that allows the target to be attacked. So first thing I'm going to do is I'm going to set the SRV host. So set, and this is case sensitive, so SRV host. By the way, this is also tab complete. So if I do just SRVH and hit tab, it fills everything else in for me. Now this particular Kali system, the public IP address is 216.6.1.100 in this lab anyway. And we can see went ahead and set the SRV host to that. At the same time, I want to set SRV port, again tab complete, to port 80. Now the reason for this is if we look into a web browser, by default, you would just simply go to www.youtube.com. And that looks perfectly normal. That's exactly what you would expect to see. However, I can make this listen to a different port. So I could do youtube.com:8080. And that would then look onto port 8080 on youtube.com. This works. This is a technical feature built into the web browsers, allows me to listen onto a different port. However, this 8080 looks a little questionable, so maybe we don't want to do that because that can raise some red flags. So we want to change our SRV port from 8080 to just 80. All right, so we set the SRV host, we set the SRV port. I also want to set the URI path because I know the person that I'm sending this email to has something to do with finances or business in some way. I'm actually going to send him to a URI path called tax. All right, so now we have all of our options set. That is our weaponization. Now we need to actually deliver a payload. So that's our attack. That's how we attack the web browser, is with this exploit. This exploit right up here is how we attack it. Along with the attack, we want to execute some code, and that code we want to be a payload that allows me to connect back, or allows that computer to be able to connect back. For instance, if I do a search type :payload, this will give me a list of all of the possible payloads in Metasploit, and there are a lot of them. Almost all of them, to some degree, is a reverse connection. Reverse. And what that means is, if we look back at our browser or our network diagram here, we know that our backtrack machine cannot attack the XP Pro because of this firewall. The firewall blocks the internet from accessing internal network. However, the XP Pro machine can go out through the firewall, can do an outbound connection. So inbound doesn't work, outbound does. So therefore my payload should be a reverse connection. It is allowing the XP Pro to reverse back into me. And then I can use that connection in order to further attack the machine. So set payload, again, all uppercase, Windows/interpreter /reverse _ TCP. All right, it accepted it. So now if I do a show options, I see now my payload options, or my payload, and I have a couple of different options down here. First thing I need to do is the lhost. Set lhost. And this is going to be the same IP address as my current machine, or the same public IP address. And in this case, I'm actually going to leave L port to 4444. If I knew I was reaching against a security conscious organization, the firewall team would see that and might actually do something about that port. I'm not too concerned about it in this case. Now, the reason why this lhost is different than the server port up above is because I could actually have two backtrack systems, or two Kali systems out here. This guy right here could hold my web page. And so the web browser on the XP machine may go down there to that machine. It will then deliver the payload up to the machine, and then the payload can tell the computer to, instead of connecting to the first backtrack, connect to this one. So maybe the one that holds the web page, I don't necessarily have a whole lot of control against. I'm just putting my attack out there. And then I'm sending everybody back to my private machine, or my personal machine, that I have a little bit more control over. So I can actually separate these out into two different machines if necessary, based on those options. Or I can have everything point to the same one, like I'm doing here. So in this case, I'm setting the SRV host and the L host to the same IP. I could do them separate. In this case, I don't necessarily need to. All right, and now in order to kick this off, I just simply kick or call exploit. I could also call exploit-z-j. If I call just exploit, what will happen is it'll sit there and it will just listen for one connection. Basically, it's setting up a URL. If somebody connects to it with a web browser, it will attempt to exploit it, and then that's it, just the one web browser. Somebody else connects to me, nothing. With the -z-j, it will accept as many possible connections as I can send to it, up to about 65,000, and it will hold on to those, and then I can exploit all of them, or do further exploits on all of them at the same time, or individually. What I'm going to do, because this is a spear phishing, I'm just going to run exploit. I'm only expecting one client to connect into me, so I'm just going to take the one. So here we can see is go ahead and starts running, sets up the reverse handler on port 4444, and then sets a URL to right there. Basically, what I've just done is I've just weaponized a URL, a web page. If somebody browses to that web page, it's going to attempt to attack that client or attack that browser. That was my weaponization stage. All right, so if that was my weaponization stage, the next step is going to be delivery. Now, almost always delivery occurs via email. It kind of sucks that such a great tool such as email becomes such a nightmare because it's being used for weaponization across the board. But that's kind of how it works nowadays. Now, there's better ways to do this, but I'm actually going to, in order for most visibility, I'm going to set this up in Outlook. Basically, I'm just going to set myself up as a POP client. I'm going to call myself Commissioner, with an email address, commissioner@irs.gov. And then for the POP and SMTP servers, I'm going to point to the POP and SMTP servers of the XYZ company, the company that I'm attacking. Next and finish. And I'm not going to try to send and receive. I'm just going to create a new email. For right now, I'm going to leave the to and the subject lines empty. Let's go ahead and say that we're part of the IRS. And we're sending a message to the XYZ company. Let's see, your company and others in the New Jersey area are eligible for a special refund because of Hurricane Sandy. This refund has already been approved by Congress. Probably the U.S. Congress. You can apply for the refund by filling out the form on our website, www.irs.gov/tax refund. Sincerely, IRS Commissioner. All right, so you've probably seen an email similar to this, including the bad spelling. Because this is an example, I'm not really too concerned about the bad spelling. I would actually want to clean this up a little bit to make it a little bit more trustworthy. Now, what I want to do is I actually want to change this URL. I want it to look like it's going to the irs.gov, but I don't want to send it there. I want to send it somewhere else. And there's lots of different ways to do this. Because of the version of Outlook I'm on, let's see, can I... Oh, I can change the URL right here. So, yeah, sure, I'll do it right here. What I'm going to do is I'm going to go ahead and change the URL or the actual link to my server. 216.61100. No, that wasn't what I wanted. Okay. So what I'm going to do is I'm actually going to save this. I'm going to go with the way I should have done it before. Do save as. By default, it tries to save it as an HTML page. Just for simple tracking of it, let's call it IRS refund. And that will save it as an HTML page, and then I'll close this and not. All right, so what that did was here in my documents directory, I now have an IRS refund.htm. And if I open up Notepad, drag and drop that into here, and it looks like garbage. What am I looking at here? Why do I see this all kinds of crazy stuff here? Well, this is where knowing a little bit about HTML comes in. Hackers know HTML, so it's kind of helpful for us ourselves. Basically, the line that we're looking for of interest is this line. This is what's called an A tag or an href. Basically, how it comes out is we start off with this section right here that's in the rectangular brackets, or less than, greater than. This is the part that the computer actually pays attention to. And then the part until we get into the up to the /A here at the end, that is the part that we see. So we have a friendly version versus the computer version. What we as hackers would do is then change the computer version to something else. In this case, instead of irs.gov, I'm changing it to the IP address of my machine that I want to use in order to compromise this computer. Now, this machine, I could have very briefly spun up this machine on Amazon or on Azure or some other cloud service provider. Just a credit card away, I spin up a virtual machine, I get a public IP address, and then I can start using it to attack other companies. Okay, so we have the section that the computer sees, and then we have the section that we see, and it's kind of hidden. One is hidden from the other. So even though the end user will see irs.gov, we're actually sending it to the attacker. Let's go ahead and save that. Close it, save. And then we'll come back in and we'll finish up our email. Let's see, insert file, irs.refund. And now instead of insert, I'm gonna actually click this little arrow next to it and say insert as text. So it inserted the text. It looks perfectly normal. Let's see, let's go ahead and insert some pictures. Let's add in the IRS logo, which IRS was so nice that you just go to their webpage and it's right there. It's awesome. And then we start typing in who we're sending this to. We are sending this to R. Miller at xyzcompany.com with a subject of IRS refund. Now, hopefully I know who R. Miller is. I know that they have something to do with taxes. I know that they are in New Jersey. The reconnaissance phase helps me plan. And then hopefully I've gone through and I've spell checked all of this so it doesn't look horrible like this does right now. So go ahead and click send. And our attack is on the way. It is in process of being delivered. Let's see. Okay, so we did reconnaissance before we even started. We went through the weaponization. We created a web page, a URL that is malicious and will attack the machines as soon as they connect to it. We then just delivered it. It's waiting in the inbox for R. Miller. And when they click on it, we will get to the exploitation phase. So let's go ahead and go on to R. Miller's machine here. So I'm currently logged in as R. Miller. Let's go ahead and open up his email. And almost immediately his email should have a message in it. And let's go maximize this right here, or open this up. And we can see here's the email we just sent. It's from Commissioner to R. Miller, subject IRS refund. And this, while probably looks a little sketchy since the IRS doesn't really send emails, this could be from some other organization, and on its surface would look legitimate. In this case, the IRS doesn't send emails, so it's not necessarily legitimate, but if it was some other organization, it could. If you have been involved in any kind of cybersecurity training or internet awareness or cybersecurity awareness, you know that the one thing you should do is hover over this link. And then you see down at the very bottom, right there, is the link that it's actually going to. This is the friendly. This is the computer. So when I hover over that link, then it tells me where it's actually going to, and that tells me this is not going to irs.gov. What's up above does not equal what's down below. This is a concern. This is the one thing I should be worried about. I should not click this link. Luckily for hackers, not everybody goes through the process of doing this, especially not on first glance. Not if they think that they're expecting this email. Now, we sent this link via email. There's lots of different ways we could have sent this. We could have sent it via social media. We could have sent it via text or chat message, or writing it on a Post-it note and handing it to somebody. We could have even done like a QR code or some other way in order to send that URL to someone. So in this scenario, I'm Reggie Miller. And I'm not entirely sure. I don't look down below. I don't see what that is. I was expecting something from the IRS, so I go ahead and I click on that link, and it sends me to a web page, and it doesn't work. Something's broke. Well, average end user, something on the internet is broken. That's pretty normal. From an end user standpoint, something on the internet being broken is completely normal. I'm going to just accept it as is. I'm going to close that down. Maybe I'll come back to my email and I'll mark that as unread. And then I'll come back to it later. Because, hey, I want that tax refund. Well, at this point, our attack has been successful. We have delivered our attack plan, or our weapon to the end user, and they're ready for exploitation. We can execute at this point whatever code we want on that machine. We're set. We're in. Awesome. If we go back to our backtrack machine, we can now see that there was some status information. Let's see. The exploit was connected and run. Page was run, interpreter session was created, so the reverse TCP connection was created along with the session ID 1. It saw it was already running iExplorer.exe. People close browsers quite a bit. We don't want to stay in iExplorer, so it spawned out the notepad.exe and then migrated over to it. So it went from one process to another. At this point, there's a notepad running on that computer, but it's running in the background, and nobody knows about it. That's it. We're on the machine. We are now able to exploit it. So if I run the question mark command, this gives me all the options I can run in Metasploit. Back up to the top here. All right, so we have some core commands. These are just basic Metasploit commands. Connect, info, jobs, kill. These are basic Metasploit commands. If there's a database, the local Metasploit database. That's not right. Oh, I'm sorry, I'm missing one. Sessions-L, start off there. I jumped a step. Sessions-L, the -L for list. Gives us a list of all the sessions. Currently, we only have one because we told it only listen for one. We can then type sessions-I for interactive mode, and then we want session ID number 1. There we go. Now we're in interactive mode, and now I can do the question mark. And now it gives me all the commands. All right, core commands: BG kill, close, exit. Then we have the standard APIs such as cat, read the contents of a file, download files, edit files, change the directories, working directory, delete files. Networking commands, I can see ARP to see what kind of machines are on the local network. I can run IF or ipconfig, route to see the routing tables. Various system commands such as reboot or shutdown or shell to drop into a command shell. If the computer has multiple screens, I can get desktops. I can see a key scan, so I can do a key scan start, stop, and then dump in order to do a capture of the keystrokes. I can even do a screenshot in order to capture the screenshot of the end user. If there's a webcam on this machine, I can do webcam list and then webcam snap in order to take a snap of what's currently in front of the webcam. Get system in order to elevate permissions from an administrator user to a system admin. And then dump the hashes as well as timestamp. Not exactly sure what timestamp is. So let's go ahead and let's start off with just a couple of those commands. If I do a pwd, it tells me what directory I'm in on the affected machine. Get PID tells me the process ID of the notepad that I'm currently running in. I can do a PS in order to list all the processes on that computer. Let's see. It's at 1040, right? There's my notepad that I'm currently running in. And then I can see all the other processes, such as the iExplorer that was running in order to allow me to exploit. And somewhere in here is Outlook. Somewhere. Let's get some more interesting ones. Let's try screenshot. This will take a screenshot of the end user's computer and then open it up for me. And I can see, yes, they were in Outlook Express. And they were looking at my email. Since I'm here, might as well get the hashes for all the passwords on the local machine. Just dump those out to a text file. Once I've got those hashes, I can go ahead and start hacking them offline and use Kane or John the Ripper or any other hash cracking. All right, so there we go. We have our process that we started off with as far as our reconnaissance, and then we went into, there we go. We started off with reconnaissance. That was actually previously done for us, so don't worry too much about it. We built a weaponized our web server and included a payload along with it. Once we weaponized our web server, we delivered a link to an end user via email. Could have been USB, could have been most anything that we could have imagined. We then exploited the web browser. The web browser. It's not an application, or it's not an operating system, but we still exploited the web browser and executed code. See, we did some level of command and control here, as far as remotely managing the machine across port 4444. And performed hands-on activities. Took a screenshot, we browsed around the operating system, we saw what was there, and now we finally get out. If I really wanted to be picky or malicious against this client, I could actually do a format on the local computer on my way out, so then it will delete all the logs, all the activity on this machine. If no other errors have been raised, it may just end up in the IT department as a broken laptop or a broken machine. They reinstall the operating system and everything's fine. Nobody ever knows a hacker. So there we go. We've gone ahead. We've done our spear phishing. We've attacked the machine, and we are good to go. A few things we could have learned through this. We didn't necessarily see any of the reconnaissance. We weren't able to protect against the reconnaissance stage because we didn't necessarily know what happened. From a security engineer standpoint, we couldn't really have done anything against weaponization. From a security engineer for the XYZ company in this scenario, the weaponization happened outside of the scope of the organization. We didn't see it. It was completely invisible to us. It just happened. We could have protected ourselves against the delivery. And there's lots of ways we could do it. Spam filters oftentimes are one way. There's web application firewalls, which might also filter the data. There are what's called next-gen firewalls that would have inspected the data as it was coming in and possibly identified that URL as being bad. We could have been using a newer version of Outlook that would have made it a little bit more obvious of the fact that that email, the link in the email didn't quite line up properly. And then also our Exchange server or our mail server could have been configured to identify the fact that even though the email said it was from irs.gov, came from an IP address that was not irs.gov. So there was a lot of ways we could have stopped that at the delivery stage. We could have also done several things at the exploitation stage. For instance, in this case, the user was an admin on the local computer, which enabled the attacker to be able to more easily get in. If the user just simply wasn't an admin, then that would have stopped the engine or the attacker from getting in and exploiting the machine. Along with that, we could have done AB/anti-malware in order to protect against possible attacks such as that. Let's see, what else could we have done? We could have done end user training. By training the end users, they would have identified the email as being malicious and stopped them from coming in. And then after that, we could go even further, such as whitelisting the applications that should run on the computer, and then stopping them from running their other non-whitelisted programs, such as this one. So there was a lot of ways we could have protected ourselves at the end. Kind of similar to what we saw with the exploitation with the installation. Command and control. This is probably the most interesting part here, is if we have a next-gen firewall, even if the vulnerability gets into the organization, even if the machine gets exploited and malware gets installed, a next-gen firewall would be able to identify the traffic that's actually happening between the computer and the internet. In this case, it was running on port 4444. A next-gen firewall should be able to identify that and block the command and control traffic. Sometimes this will actually run on port 53, since DNS runs on 53, and nobody pays a lot of attention to it. Next-gen firewalls would see that traffic, see that it's on 53, but the fact that it's not DNS, it would then block it. So command and control could actually be blocked by a good firewall. And then lastly, actions on the objectives. Again, if the end user doesn't have admin rights, they don't have a lot of access to the machines. Admin rights. If I've segmented my network, then that also limits how many machines can easily be accessed by the hacker once they've accessed my machine. If I have proper security controls, such as passwords and smart cards, they may be able to access one machine, but they wouldn't be able to access anything else in my environment, including things such as having websites, secure websites internal to my organization that are just as secure as if they're on the internet. Great thing there, somebody attacks my machine, they get my machine, but they don't necessarily get access to my web server items. So there we have it, spear phishing in the organization. Spear phishing to target an organization. It's actually not that hard for an attacker to do. Once they know what they're doing and how to get in, the actual process is fairly simple. However, at the same time, protecting the environment can be simple as well.